In today's podcast, we are going to see about enantiomers and diastereomers. First, let us see about enantiomers. In 1848, Louis Pasteur he made an interesting observation that optically inactive sodium ammonium tartrate it existed as a mixture of two different kinds of crystals, which were mirror images of each other. With the help of an hand lens and just a pair of tweezers, he was able to carefully and laboriously separate them into right and left handed crystals. Although the original mixture was optically inactive, each set of crystals, when dissolved in water, was found to be optically active. Furthermore, the specific rotations of the two solutions they were exactly equal in magnitude but opposite in sign. The two set of crystals they are indeed enantiomers. Now, what are these enantiomers? Enantiomers we can say are optical isomers which are related as non-superimposable object and its mirror image. If a molecule is non-superimposable on its mirror image, then the molecule is said to have an enantiomeric relationship with its mirror image molecule. Let us consider two examples. Example 1, 2-chloropropane. If you see the structure of 2-chloropropane, the molecule is superimposable with its mirror image. So they are identical molecules. But if you take 2-chlorobutane, the molecules are not superimposable with its mirror image and the two molecules are said to be enantiomers. Thus, enantiomers we can say are stereoisomers that differ only in the relative arrangement of different groups in space but not in bond connectivity. Enantiomers are identical in all physical properties except optical rotation and chemical properties, and the reactivity is compared to an achiral agent in reactivity. For example, D and L erythrosis. D and L erythrosis, they are mirror image. So they are called as enantiomers. Similarly, D and L triosis, they are mirror images. So they are called as enantiomers. Now let us see what diastereoisomers are. If two molecules are not mirror images, but still they are stereoisomers, they are said to be diastereomers. For example, we said that um, D and L erythrosis are mirror images, but D erythros and D trios they are not mirror images. So they are said to be diastereomers. Same way D erythros and L erythros. L erythros and D trios. L erythros and L trios. They are diastereomeric pairs. So, what are diastereoisomers? Diastereoisomers, they are different geometrical entities, but enantiomers, they are identical geometrical entities. For the diastereoisomeric relationship, chirality is not essential property. For example, if you take cis and trans isomers, they are diastereoisomers. And a single asymmetric center cannot show diastereoisomerism. Epimers are also called as diastereoisomers. So in short, we can say that stereoisomerism other than enantiomerism is called as diastereomerism. Diastereomers are otherwise called as diastereomers are stereoisomers which are not related as mirror images. So they are characterized by differences in physical properties, but by some differences in chemical behavior towards achiral as well as chiral reagents. In short, we can say that a diastereomeric pair has got different sign of optical rotation. They are separable in TLC. They have different RF values in TLC. They have different delta values in proton NMR and C13 NMR, and they have different. They can be isolated in. There is a difference in LCMS, HPLC, GCMS, and they have different melting point, boiling point, solubility, refractive index. The rate of reaction in chiral medium and achiral medium is also different for diastereoisomeric pair. Now let us see the difference between enantiomers and diastereomers. The notable 3 or 4 differences between enantiomer and diastereomers are: an enantiomer we can say is one of the two stereoisomers that are non-superimposable complete mirror images of each other. Whereas diastereomers, they are stereoisomers that are not enantiomers, that is, they are non-superimposable mirror images of each other. Molecules they must contain at least one chiral center. In the case of enantiomers, molecules must contain more than one chiral center in the case of diastereomers. Enantiomers have, when present in a symmetric environment, identical chemical and physical properties except for the ability to rotate the plane polarized light by equal amounts but in opposite direction. Whereas diastereomers, they have different physical properties and different reactivity. In another definition, diastereomers, they are pair of isomers that have opposite configuration and one or more chiral centers but not mirror images of each other. Underline diastereomers, they are not mirror images, they are non-superimposable, non-mirror images of each other. And enantiomers, we can say a mixture of equal parts of an optically active isomer, and its enantiomer is termed racemic and has a net rotation of plane polarized light of 0. Whereas the racemic mixture is not possible in the case of diastereomers. So these are the significant notable differences between enantiomers and diastereomers. Thanks for listening.